A couple of lessons ago, we started exploring transformations of quadratic functions, and today we're going to look at transformations of linear functions. Now, the good news about that is the linear functions, the transformations, follow the same rules as the quadratic functions. So when we're translating, that means we're shifting. We can either shift vertically. That'll be these guys are going to shift vertically, and these guys are going to shift horizontally. So just like in our quadratics when we had the plus k at the very back of the equation, our y-intercept plus b is going to cause a vertical translation, and in this case it's going to be up 2 units. Up 2 units. And the other one is going to be a vertical translation. Down 2 units. And remember what we were running into in the quadratic functions when we had the numbers inside the parentheses. That was the whole x lies. So we're going the opposite direction when we're inside parentheses. So this one's going to be a horizontal translation, and it's going to be 1 unit to the left because it's going the opposite direction. And this one's going to be horizontal, and it's going to go 1 unit to the right. Now, we also had reflections where we reflected across the x-axis. Now, in quadratics, we were looking at the negative sign in front of the a value. In linear, we're going to be looking at the negative sign in front of the slope. So if our slope has a negative sign, then we're going to say that our graph reflects across the x-axis. Now I know that last year when you were looking at slope, you learned that this is a negative slope. It's a downhill line, and that's still true. But the actual transformation is it's reflecting across the x-axis. And then finally what we looked at in quadratics was we looked at vertical stretch and vertical shrink. We were looking at the a value irregardless of the negative sign, just looking at the absolute value of a. If that number was bigger than 1, then we had a vertical stretch, making it a narrower parabola. And if our number was less than 1, so between 0 and 1, a fraction, we had a vertical shrink. We have the exact same thing happening in linear. When our slope is a number greater than 1, we have a vertical stretch. Now in linear terms, that means the line is steeper. And if we have a slope that is less than the number 1, we have a vertical shrink. And in linear terms, that means the line is flatter. So now let's just take a moment and look at the linear parent function. So the equation for the linear parent function is y equals x. So our slope in the linear parent function is a slope of 1 and a y-intercept of 0. So what I want you to do is to pause your video and fill out the table and graph the linear parent function, and then start the video up again. Okay, so now that you have the parent function, the table, and the graph, I want you to take some time and look at number 1, number 2, and number 3 on your own, and I want you to determine what the transformation is from the linear parent function to function g that you've been given. So go ahead and complete 1, 2, and 3 on your own. Pause your video while you're doing it, and then check back for the explanation. Okay, so just compare all your answers. They were pretty straightforward, following the rules in the same pattern that we had in quadratics. Now on number 4, 5, and 6, it gives it to you more in a verbal description. So I want you to answer and describe the changes in 4, 5, and 6 on your own. Pause your video while you do it, and then check back for the final explanation. So again, this was just following our rules. The biggest thing is getting you used to also realizing our slope, the number, the coefficient in front of x, is going to cause the stretch and the shrink. And our y-intercept, that's the plus a number plus b or minus b, is going to do our vertical transformations or our translations.